Today's lesson is on solving inequalities using multiplication and division. The two state standards that we will address today are PA.A.4.2 and PA.A.4.3, and this is Dr. Morrison. The big question we're going to answer today is how do we solve inequalities by using multiplication and division? We're going to do that in 5 different ways. The first thing we're going to do is solve by multiplication, and then we're going to graph that inequality solution with that multiplication example. We're then going to solve by division, and then we're going to solve more difficult problems in both multiplication and division, and we're going to graph every single example today. A basic question that we do need to answer before we move on is, what is an inequality? So the standard definition of inequality compares two values, showing if one is less than, greater than, or simply not equal to another value. So as you can see, there's an A and then there's a sign between the A and the B. That shows an equal sign with a line slashed through it. That means that A is not equal to B. The next line there says A and then a less than sign, or a kind of a sideways V next to the B. That is saying that A is less than B, and then you flip it around where it looks like it's kind of like trying to eat the A. That suggests that A is greater than B. So as you've gone through elementary school, you probably have an understanding of what these signs mean, and you've seen them before at least. But I've given you 3 examples on the slide here. The first one is saying X is less than 7. The middle one is saying 10 is less than Y, and then that bottom one says Z is greater than 20. We're going to rely heavily on our book for today's lesson, so let's take a look at our book for our first example. Our first example asks us to solve x over 5 is less than or equal to -3. And that is a less than or equal to sign because of that line underneath the less than sign. Step number 1 with our first problem, as will be step number 1 for every problem today, is to write the inequality down. Basically, write the problem down on paper so that you can begin working it out. Our next step asks us to begin working through it mathematically. So as we can see, we have x over 5 is less than or equal to -3. What they're suggesting you do is undo the division, or what we've been discussing all along is the inverse operation of what's going on with the variable to isolate the variable. So this is x divided by 5. What we need to do is the inverse operation of division. The inverse operation of division is multiplication. So we need to multiply both the left side of the inequality by 5 and the right side of the inequality by 5. As you can see, once we multiply the left side by 5, the 5's canceled each other out, and we were left with x. And then on the right side, we had a -3. And when we multiplied that by a +5, it gave us -15. So we ended with x is less than or equal to -15. Our book wants to make it a point to let you know whenever you've solved a problem or whenever you've come up with a solution. And at this point, since there are no other like terms and there's nothing else next to the x, we have our solution, and it is x is less than or equal to -15. What we need to do now is graph it on a number line. So as you can see at the bottom of your screen, we have a number line that goes all the way back to -40, and then it goes all the way in the positive direction to 10. So the dot, or the circle, that was put on this line graph here is a closed circle. And the reason it's a closed circle, or a circle that's colored in, is because our inequality in this actually has an equal sign with it, which means that -15, that number, is part of our solution. So that needs to be closed in on the -15. And since x is everything that is less than or equal to -15, we need to shade in the part of this line graph that is everything that's below -15. And when we're talking about below a negative number, we're going left. We're going towards more negative numbers. Let's look at another example. This time we're going to use division. So the problem that we have to address here is solving 6x is greater than -18. And we're going to be asked to graph it as well. Again, as always, we suggest that you write down the problem on paper so that you give yourself some space to begin working it out. This will always be our first step. Our next step asks us to begin isolating the variable. So we want to get the x by itself. Now the x and the 6 have a relationship, and that relationship is multiplication right now. So the book says to undo the multiplication, but as again, what we're always doing is the inverse operation of what is happening to the variable, and what's happening to the variable is multiplication. So the opposite of multiplication is division. So when you undo multiplication, you divide, okay? So we're dividing both sides by 6 to get the x by itself. On the left side, we're going to have 6 divided by 6, and on the right side, we're going to have negative 18 divided by 6. Whenever you work that out, on the left side, you have 6 divided by 6, which gives you 1, or 1x. You don't need to write the 1 in front of the x. It's an understood idea. And then on the right, we have negative 18 divided by 6. And a negative divided by a positive will give you a negative, and 18 divided by 6 is 3. So we ended with x is greater than negative 3. Again, the book likes to outline the point when you have arrived at a solution, and the solution to this particular inequality is x is greater than negative 3. We now need to graph our solution on a number line, and our solution is x is greater than negative 3. It's not x is greater than or equal to. That's really important that we understand. It's just x is greater than negative 3. It's everything above negative 3, okay? So on our number line here, the circle that we put on negative 3 needs to be open because negative 3 is not part of the solution. The solution is everything that's above negative 3, okay? So on your number line, it's an open circle on negative 3, and it's everything going to the right. And the reason it's going to the right on the number line is to the right is all the numbers that are above negative 3, okay? Negative 2 is above negative 3, 1 is above negative 3, 74 is above negative 3. So the solution to x is literally anything that's above negative 3, and that's how you show it on the line graph right there. Okay, so let's take a look at a more difficult problem involving inequalities using multiplication. The problem that we're going to look at now is negative 3 over 2n is less than or equal to 6. I want you to think about what our first step would be here. What do you think we do first to solve this problem? If you said rewrite the inequality, you are correct because that is always our first step. Let's write the problem down on paper to get started. But what do you think your next mathematical step would be? What do you think you do first? If you said begin isolating the n, trying to get the n by itself by getting rid of the negative 3 over 2, you are correct. So how do we get rid of a negative 3 over 2 that's being multiplied by an n? Well, we do what we've been doing the last few lessons, and that's the inverse operation. The inverse operation in this case is going to be division because negative 3 over 2 is being multiplied by the n, okay? As we discussed in a previous lesson, whenever you have to divide by a fraction, you have to multiply it by its reciprocal. And the reciprocal of a fraction is its flipped version. So as you can see in red there, they're multiplying both sides by negative 2 over 3 because that is the reciprocal, the flipped version of negative 3 over 2. Once you multiply both sides by the reciprocal, on the left side you end with a positive n because you had to multiply a negative 3 over 2 by a negative 2 over 3. And as we know, a negative times a negative is a positive. On the right side, we had negative 2 over 3 times 6. And once you simplified that down, you ended with negative 4 because on top you would have had a negative 12. And on bottom you would have had a 3. So negative 12 divided by 3 would have given you a negative 4. Now there's something interesting here that we want to kind of look at. Something happened to our inequality sign. What was it? If you said the inequality sign flipped, where it was no longer a less than or equal to, but it became a greater than or equal to, you are correct. That happens whenever you multiply or divide across the inequality sign by a negative number. And as you can see, we multiplied both sides by negative 2 over 3. And when we did that, our less than or equal than sign that we started with flipped and became greater than or equal to. And our solution to this ended at negative, or n, is greater than or equal to negative 4. We now need to graph this solution. So again, our solution was n is greater than or equal to negative 4. That greater than or equal to sign means that it needs to be a closed circle on negative 4 because that means that negative 4 is part of the solution. And the greater than part of it means that it's everything to the right of our number, okay? So negative 3 is greater than negative 4, 0 is greater than negative 4, 22 is greater than negative 4. Everything to the right of negative 4 needs to be shaded in because every one of those numbers can be part of our solution. We've arrived at our final example. This is the more difficult division problem. So we're being asked to solve negative 3z is greater than negative 4.5. What do you think your first step is? If you said to write the inequality down on paper, you are correct. That again is always our first step. Write it down to give yourself some space to be able to work it out. But what do you think your first mathematical step is? Again, if you said your first step is to isolate the z or try to get the z by itself, you were correct. And in this case, we need to get rid of the negative 3 to get the z by itself. And the relationship between the negative 3 and the z is multiplication. And the inverse operation of multiplication is division. So that's why you see in red there, they're dividing both sides by negative 3. The book always says undo the multiplication, but what you're really doing is performing the inverse operation. So what do you think will happen to the left side whenever we divide by negative 3? If you said the negative 3's cancel each other out and just give you the variable z by itself, you would have been correct. On the right side, we needed to divide negative 4.5 by negative 3, and when we did that, we got a positive 1.5. The reason we got a positive 1.5 is because a negative divided by a negative is a positive. And as you can see again, our sign, which started as a greater than sign, has become a less than sign. And that is because we divided by a negative 3. Anytime you divide or multiply by a negative number across an inequality sign, that inequality sign will flip. As always, the book likes to point out the moment that you arrive at a solution. Our final solution for this particular problem is z is less than 1.5. So before we graph it, what direction do you think the line will go on your line graph? Do you think it's going to go left or do you think it's going to go right? If you said the line was going to go left, you are correct. And also the circle on this one, the point 1.5 needs to be open because our solution was z is less than 1.5. 1.5 is not part of the solution. It is the moment where our solution starts, but it's not included in our solution, okay? So if z is less than 1.5, it is everything below 1.5. And to indicate that on a line graph, you basically shade in everything to the left of your solution. And this concludes today's quick lesson on solving inequalities using multiplication and division. Our standards that we began addressing today were PA.A.4.2 and PA.A.4.3. If there was a particular example today, either example 1, 2, 3, or 4, that you felt like you need more time in, please feel free to go back to that particular slide or part of the video and rewatch it.